Welcome to day 2 of our fourth quarter review. Yesterday we got through questions 1 through 6 in our review packet, so today we're going to pick up on question 7. Question 7 is where we learned about a couple of formulas that we're able to use to help us solve a system of equations, and you can see those formulas on your review packet. Because the formulas are on the review packet, that would mean they would be on the test that you'll be taking as well. So on question number 7, we're going to begin to solve for the x in our question. So the formula that I have here tells me to take the b from the second equation. So remember, the equations always go a, b, c. The a is in front of the x, the b is in front of the y, and the c is the constant at the end of the question. So the b from the second equation is my 1 times the c from the first equation, 12, and then minus the b from the first equation, negative 2, so I use parentheses there because of the minus with the negative, and my c from the second equation is the 10. All over in the denominator, the a from my first equation was 6, times b from the second equation, 1, minus a from the second was 5, times b from the first, negative 2. Beginning to do all of the arithmetic there, 1 times 12 gave me 12, and then in the second part of the numerator, negative 2 times 10 is negative 20, so subtracting a negative 20 turned that into a positive 20. You also could include that minus as part of the multiplication if you wanted to. The negative times negative 2 would be positive 2, and positive 2 times 10 still gives me 20 up there in the numerator. In the denominator, 6 times 1 is 6, and then 5 times negative 2 is negative 10. Then again, subtracting a negative 10 made that positive 10 in our denominator. Doing the arithmetic next, so 12 plus 20 gave me 32, and then 6 plus 10 is 16, so 32 divided by 16 is 2. At this point, we have our answer for question number 7. We have located the x that is in this system of equation. So now let's do question 8, where we're going to find the y. So the y formula, notice the denominator is the exact same that we just did for x. So the denominator that I have here is the same denominator that I just filled on the previous slide. In the numerator, we're taking the a from the first equation, which is the 6, times the c from the second, that's 10, minus the a from the second, 5, times the c from the first, which is 12. 6 times 10 was 60, and then 5 times 12 is 60, so 60 minus 60, and again, there's the same denominator, 6 plus 10. Continuing to add and subtract, so 60 minus 60 is 0, and 6 plus 10, it was 16. 0 divided by 16, or that's not undefined, 0 divided by 16 is 0, and there's my answer for y. A quick way that I can check that, we just said that the x was 2, and I know the y is 0. So 6 times 2 is 12, 2 times 0 is 0. 12 minus 0 is 12, so it works on the top equation. 5 times 2 is 10, plus our y, which is 0. 10 plus 0 is 10. My answer works on both of the equations, so I know I have the correct answer on both questions 7 and 8. Moving on to our next section where we ran into some of our trig equations. Question number 9, we have cosine theta minus the square root of 1 minus cosine squared theta was equal to 0. On this kind of trig equation where we had a radical, the first step that we had to do was isolate the radical symbol, just like it was a main algebra question. So I added over the square root to the right-hand side. So I have cosine theta is equal to the square root of 1 minus cosine squared theta. At this point of the question, we wanted to get rid of the square root. Well, how do we get rid of a square root? We square on both sides of the question. So we have cosine squared theta now on the left-hand side. The right-hand side, when we squared, just canceled the square root. So we are left with the radicand of 1 minus cosine squared theta. We're trying to solve for the theta on this question. It's on both sides of the question, so let's get them all together. The next thing that we would want to do is add the cosine squared from the right-hand side to the left-hand side. Well, cosine squared plus cosine squared would give me 2 of the cosine squared thetas, and our equation equals 1. Well, think, okay, I'm solving a basic algebra problem. What would you get rid of next? It would be the 2. So I'm going to divide the 2 over. So cosine squared theta is equal to 1 over 2. Now we need to cancel the square. Well, how do we cancel a square? It's a square root. Remember when we square root a fraction like this, the square root would apply to both the numerator and denominator. So you would have square root 1 over square root 2. Well, square root of 1 is just 1, so you would have 1 over square root 2. We can't leave a square root in the denominator, so we would move that up to the top. So the numerator would become square root 2, and we would leave just the number in the denominator of our 2. One other thing we have to remember here, when we take the square root of both sides of the question, we have to include that plus and the minus sign. So my cosine theta is equal to plus or minus square root 2 over 2. Notice we have the cosine ratio is all by itself, so we're ready to figure out the angles at this point of the question. On the right-hand side, we have both the positive and the negative. Well, where is cosine positive? That's quadrants 1 and 4. Where is cosine negative? That's quadrants 2 and 3. That means I need to give an answer in every single quadrant of this question. Well, what angle has a cosine ratio of square root 2 over 2 that is 45 degrees? Well, that's in my first quadrant, so there is a first potential answer. To go to the second quadrant, we back up from 180. So 180 minus 45 was 135. For the third quadrant, we go past 180. So 180 plus 45 is 225. And then the last answer in the fourth quadrant, we back up from 360. So 360 minus 45 is 315 degrees. Now, if you noticed in the instructions on these questions, it says don't forget to check your answers. That's very important on both of these questions here on numbers 9 and 10. If you remember, a square root question, anytime that you have a square root, this part of the question is going to be a positive number. So what kind of number subtracting with a positive number would give me a 0? Well, this has to be a positive number as well. Like 5 minus 5, they're the same positive number. It can't be negative 5 minus 5 because that would give me a negative answer. So both of these need to be positive if this is true. Well, where is cosine positive is just in quadrants 1 and 4. That means in my list of possible answers, the 135 and the 225 are not allowed to be included because that's where cosine is negative, and I don't want negatives on this question. I just want the positives, so I would give positive 45 degrees as well as positive 315 degrees for my two answers on this question. Let's see how we need to check on the second equation. So on question 10, we have tangent theta minus square root 3 times sine theta plus 1 is equal to 0. Well, this question, we don't have the variable inside the square root like we did in the last question, but we do have a multiplication question that is equal to 0. What do we know about multiplication questions that equal 0? One of those factors has to be set equal to 0. Remember, because both of these factors are inside parentheses, is the opposite of what we would have. So the first equation that I'm going to write is that tangent theta is equal to positive square root 3, and the second equation is sine theta equals negative 1. So again, the opposite of the numbers that are inside of the parentheses. Let's go ahead and focus on that first equation. I notice tangent, and that's a positive ratio, positive square root 3. Where is tangent positive? It's quadrants 1 and 3. What angle has a tangent of root 3? It'd be root 3 over 1 if you're looking at your picture, and that would be the 60 degrees. Well, 60 degrees is in the first quadrant, so that would be okay. And to get that into the third quadrant, we're rotating past 180, so 180 plus 60 is 240 degrees. Going to your second equation, that sine theta is equal to negative 1. Well, there is no triangle that has a sine of negative 1. That means I need to use the Cartesian plane to help us come up with our answer. What was the definition of sine? It was y over r. Well, in the Cartesian plane, r was always equal to 1, so we just had to focus on the y. If I need this fraction to equal negative 1, well, then I need the y to be equal to negative 1. Y is what goes up and down on the Cartesian plane. So where does y go at negative 1? It's going down, and that's our 270 degree axis. Now that we have our potential answers, again, we have to check, are these answers okay? Answers that you would get out of a triangle, like I did over here with the 60 and the 240, those answers are always okay. It's the answers that you would get using the Cartesian plane. Those are the potential issues that we have on this question. Now, because this answer came out of the sine question, I know it's going to work over there, but does it also work in this first parenthesis? So if I were to put 270 by this tangent, well, what was the definition of tangent in the Cartesian plane? It was y over x. If you think about your 270-degree axis, so that's the one that was going down, the ordered pair down there would be 0, -1. 0 because I didn't go anywhere left or right, -1 because we had gone down one space. Well, using that ordered pair of 0, -1 in my definition of y over x, that would make that fraction -1 over 0. Can I have a 0 in the denominator? Absolutely not. So this answer of 270 is not allowed to be included because it would make the tangent undefined. So be careful of that on these kind of questions. Answers that you would get out of the Cartesian plane using your special definitions of sine, cosine, or tangent could present potential issues. If they came out of the triangle, like my first two answers, then they're okay. It's just the Cartesian plane that we got to be careful about on these kind of problems. Let's finish out with two more questions today. These will be two easy questions for us to do, where we talked about our determinant with regard to matrices. Well, how did we get to a determinant? We had to cross multiply. So we are going to take on this question our -7 times -4, and then we're going to multiply 3 times 5. So -7 times -4 was 28. 3 times 5 was 15. But don't forget, going up on that multiplication, we had to put the opposite. So I put -15. 28 minus 15 would give me 13. And there's my final answer on question 11 for our determinant. Let's do number 12 as our last question today. Again, to find the determinant, we are going to cross multiply. So 4 times 2 would give us 8. 5 times 6 is 30, but we put the opposite, so -30, and 8 minus 30 is -22. Again, if you have questions on things that we covered today from number 7 up through 12, go ahead and contact me. I'll be glad to explain those problems to you. And over the next 3 days, we'll finish up the rest of the problems that we see on our review packet.